Alright guys, today we are still in section 10.5, so still talking about those segments inside of a circle. But today we're just getting some extra practice. There's not any new vocabulary, there's nothing more to really learn except for just to get more practice so we get more comfortable with it. The first example that I have up here, you're going to notice that we've got really two chords that are intersecting inside of the circle. And again, when that happens, we know that it's dividing these chords into parts, and the product of the lengths of one chord should equal the product of the lengths of the other chord. So we can write our equation here to say that 2 times our 3x minus 1 should equal the product of these two parts. So our x minus an 8 times an x minus 5. As you distribute on this side, we'd get our 6x minus 2. And notice over here we're going to end up having to FOIL this. So we're going to get an x squared minus 5x minus 8x and plus 40. Again, we've got a quadratic equation. We've had several of these this chapter so far. Hopefully we're more comfortable with this by now. We know that we want to go ahead and we want to get all of the terms to one side, set it equal to 0 to help us to solve. So 0 is going to equal, we have an x squared, and when we combine all of our x's together, we're going to end up with a total of negative 19x, plus 42. Now from here, this is one that again it's not factorable. It's not a beautiful quadratic equation that we can factor and solve by factoring. But if I look for my a, my b, and my c and use the quadratic formula, a is 1, b is negative 19, and c is 42. So if I put this stuff into the quadratic formula, the opposite of b would be a 19. And again, if you forget that formula, opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so that opposite of b would be my positive 19, plus or minus the square root of our b squared. And be careful to always put that number that you're putting in place of a variable in parentheses, because if you square a negative 19, you should end up with a positive number. But if you didn't use parentheses around that negative 19 and you type it in your calculator is smarter than you think. It's following order of operations, but you're telling it that you're doing the opposite of 19 squared rather than negative 19 squared. So there's our b squared minus 4 times a times c, and all of this is over 2 times a. Now, as you start to simplify this, you would end up with a 19 plus or minus the square root of 193 all over 2. Well, 193 is not a beautiful perfect square either, so we're going to go ahead and just get an approximate decimal. So if you take your 19 plus the square root of 193, hit equals, and then divide by 2, you would end up with that x value being approximately 16.45. If you did the minus scenario, you would end up with a 2.55. Now, notice that both of these are positive numbers, which sometimes that doesn't happen, and it's really easy to determine an extraneous solution. But if you start plugging numbers in to check this stuff, if I took 2.55 minus 8, that is going to end up making that a negative segment length, which we know is not true. So really the only true answer here is that x is the 16.45. For this next one, notice that we've got two secant segments. They touch my circle at two places, one of them being the end point of the segment, but the other end point of our segment is somewhere outside of the circle, and that happens on both of these. When we have two secant segments, the relationship that exists between there is we know that if I take that whole secant segment and times its external segment, it should equal this whole secant segment times its external segment. So let's take a look. First of all, if I think about this whole secant segment, that's going to be an x plus 18. So x plus 18, that whole secant segment, times its external part, just the x, should equal our whole secant segment, the 18, times the external part, 8. And as you go ahead and multiply, you're going to end up with an x squared plus an 18x. And the 18 times 8 is going to give us 144. Now, again, we have a quadratic equation. We know we want to set it equal to 0, so you're going to have an x squared plus an 18x. Subtract your 144, and now it will equal 0. This one actually is a nice one to go ahead and factor. If I found factors of my negative 144, I would find that the factor pairs would have been a 6 and a 24, and to get a positive 18, as long as it's a negative 6 plus 24, that would get me my 18. You could still use quadratic formula on this as well. Any of those methods to solve a quadratic equation would work. If I go ahead and, because I have a leading coefficient of 1, use that shortcut to say we have an x minus 6 is one of the factors, and an x plus 24 will be my other factor. And because we're solving, we're setting each one of those factors equal to 0. We would find that x could be a positive 6 if I added 6 to both sides, or a negative 24. Again, because it's a segment length, it can't be negative, so x is just 6. Now, the last one that we have here, notice that we've got a tangent segment and a secant segment. That relationship that exists between these is that the whole secant segment times its external part, so our whole 4 plus 12, which would be a 16, times its external part, 12. That whole secant times its external part should equal, and we could either say that tangent segment squared, or when we're thinking about, again, its external part is the same thing as the tangent segment, 2x times itself, 2x. As we go ahead and simplify this one, 16 times 12 is going to give us a 192. And if I square 2x, keep in mind you're squaring everything here, where you're taking 2x times another 2x, which is going to become a 4x squared. Now to solve this one, you could set it equal to 0 and solve by factoring. This one's just kind of almost too easy. You could use quadratic formula again if you set it equal to 0 too. Notice that we don't have an x term. We don't have the middle term. So we could just divide both sides by 4 to get the x squared by itself. So x squared is going to equal a 48. And then we can square root to get rid of our square. This one, notice that 48 is not a perfect square. You're going to get a decimal. We technically could leave it as a simplified radical. The factors of 48 that are perfect squares would be a radical 16 and a radical 3, knowing that radical 16 would be a 4. We call that a 4 radical 3. So x equals plus or minus a 4 radical 3. Again, we know it can't be a negative segment length. Or we could use that approximate decimal. Here we don't have a label, so either one would be fine with me. So you could say x is 4 radical 3, or you could say it's approximately 6.93.